And we are live with our 173rd episode of Absolute AppSec. I'm Ken Johnson at CK Tricky on Twitter, joined by my lovely co-host Seth Law at Seth Law on Twitter. Seth, say hi.
Hey everybody, welcome back to another episode. Super excited to get together this week and talk. There's a few things that we wanted to bring up before we dive into it. I've got some, tales from code review / pen testing that I want to share here shortly. But before we jump into it, Locomocosec training. If you've been listening, that we are going to be giving our secure code review training at Locomocosec at the end of July. Please consider us if you're going to be there. We would love to have anyone. And we did get notification over the last week that we will be doing practical secure code review at DEF CON as well. So DEF CON is doing paid trainings or doing professional trainings after the conference. So it's a little bit different. We've done it for Black Hat before in the past. And anyway, right, whatever. This year we're going to be doing it after. So it's like the Monday and Tuesday after DEF CON. I think that's like the August 12th and 13th. But we'll post those links once they become available. I know they're not quite, up yet, but it'll be another great place to get the training. And I don't think the cost is going to be as high as some of the other conferences because it is DEF CON. So watch for that. Outside of that, we do have new swag shirts. I think you can't even see me, but I am wearing the new Absolute AppSec shirt today. So I've got a couple of requests that came in after last week for shirts. So we'll be sending some out in the next week. And if you would like one, jump on Slack, let us know. I'll be happy to send you one. And they're close to what the old ones were, Ken. I mean, it's the same shirt. I haven't even sent Ken one yet because, I hoard all the swag apparently. But
well, no, thankfully we now have your we have Aaron, who is amazing, and who is helping with more logistics and marketing and helping ship things, and just overall, Aaron's been super helpful for the podcast. All the little, the short clips you see on our Instagram, a lot of the tweets you see, all of that is Aaron. So thank you to Aaron behind the scenes, working tirelessly to help us out.
Yes, Aaron's doing a good job. So swag wise, if you want anything, let us know. Ken, anything else that you wanted to bring up before we jump into it?
Yeah, just that we're getting a lot of requests for corporate training. We do corporate training in case anyone's interested. We have a few options there. We modify it as needed, of course. Like some people have different needs internally than the standard stuff that we teach at conferences. But just because we keep getting asked, I just want to put it out there. Yes, we do corporate training. It's not a weird question to ask us that or anything like that. So yeah, just putting that out there.
Okay. Yep. And I think we are going to drop if you've got questions concerning corporate training, hit us up either at, Seth or Ken at absoluteappsec.com or even just info@absoluteappsec.com. We'll throw a button on the website here in a little bit about that. And we have been talking about sponsorships as well. That's another, option for people. We may go that route. If you are interested to talk to either of us about that, please reach out. Okay. Outside of that, we can get into tales from penetration testing. All right. So one of the items that I've been seeing over and over and over the last 2, 3, 4, I don't know, however long I've been doing this for 3 years, right, Ken? Something like that.
Yes.
But one of the biggest items that we find in practically every test is user enumeration. And being able to guess what someone's username is or determine what someone's username is from an unauthenticated state based on application responses. So when we talk about assessments, we always talk about AAA, right? Ken, what is AAA? It's
Authentication, authorization, and the lamest of. No, I'm joking. Auditing. Seth's
auditing.
No, actually, auditing is incredibly important. joke about how boring it is.
Yes. So like we always talk about that authentication, obviously that's one of the huge security principles, being able to identify users, figure out who they are. But most applications leak out information to unauthenticated users, specifically around whether or not a user exists and has an account with that application. And like can be through like the login screen. I know we always talk about VTM, like the vulnerable task manager that we use for training, but on the login screen there, it'll give out different error messages based on whether the user exists or not. I don't always find it on the login screen. It's very rare nowadays that I see like user error messages on the login screen. I don't know about you, Ken, but that's not one place that I'm seeing it. But I do see it more commonly during the registration process, the forgot password process, and forgot username process, right? Those other authentication routines that people forget about, right? Whenever I say authentication to most developers, they instantly just think about credentials, like username, password. And that seems to be the only place that they think that they're identifying users. But we know as security people that we identify users via other mechanisms, and the forgot password, forgot username, registration process are all authentication routines that have to be secured. But it's very difficult to actually solve user enumeration during those authentication flows. It just is, right? Like registration, you've got to tell somebody whether or not that email address is already associated with an account, because you're not going to have them sign up again. So there's recommendations that we put in there around, hey, out of band communications, we don't respond on a single request on whether or not a user actually exists. So this is all background, right? This is all background. I'm testing. We're looking at an application recently that makes use of security questions, right? So if I need to reset my password, it presents me with a screen that says, okay, answer these security questions that you filled out during the registration process, and we're going to let you reset your password, right? Now, obviously, there's a couple of issues there, right? Or couple, not necessarily issues, but security concerns that we have with security questions.
Yeah, those I hate those. I really do. I hate those. Is the sole mechanism for recovery. Yeah, no bueno, no good.
No bueno. Yeah, I mean, I think and they seem to have fallen out of favor, to be honest with you, right? Like I don't see security questions as often as I did 10 years ago, right? Like it seemed to be the initial, hey, we're going to ask you what's your favorite car, your mother's maiden name, those list of whatever.
All the stuff you put on Facebook.
Yeah, exactly. Which is part of the reason that we got away from it. But there are still systems, especially in the corporate world, that use security questions. And this application happened to be one of them. Now, the developers of this application decided that, hey, security questions, this is a great way to solve the forgot password flow, right? They still wanted to use it, but the initial request was, hey, tell us what your username is. And if you put in a username, it redirects you to the security questions page, right? And so the traditional problem that we would see user enumeration wise in this flow is that if a username doesn't exist, it does not redirect you to the security questions page, right? But this application was not vulnerable to that. The developers at some point had said, no, guess what we need to do? If a user does not exist, it still actually pushes the requester to the security questions page, right? And so I'm like, all right, well, that's cool. So there's not the flaw there on the initial form as you're going through. But then I started to examine the security questions page. Now, my question to you, Ken, as a developer, what security questions do you display when a user does not exist?
I mean, you're asking me to fit within guidelines parameters I wouldn't be using. But let me play the part of a developer. I'd probably randomize, the same questions I would Like, I don't know,
Okay.
assuming there's like, say, a set of 15 questions and they have users randomly assigned or pick from, say 3 out of that 15 that are available options. Well, then I'm going to randomize. I guess the only issue with randomizing in that case is that you'd almost have to create a temporary allocation of security. So like if I picked 3 random questions from the 15, if you were to re-enter that email address or username, I would then need to basically keep in memory the 3 I had chosen to show those same questions again, because otherwise you're going to run into the situation where, like, assuming, like I said, that when somebody sets up their security questions, they're selecting 3 out of 15, and it's only going to be those 3 security questions. You don't want those security questions to rotate if you're making it up, right? If you're trying to emulate that there is a user. I guess those are the guidelines or parameters I would fall within.
Yep. And you're absolutely right. So, and this is the flaw that I saw on the user enumeration page, or on the security questions page, is that I would go in, and every time I put in a non-existent username, the security question set would change every single time I loaded that page. Whereas, and so the set was having, there was, it's exactly the scenario you're describing. They had, 10 security questions that are in their list, and you pick 5 of them. They display on that page so you can reset your password. But if the user doesn't exist, it displays 5 security questions. But the next time that I submit that form, it displays another 5, or they're in a different order. As opposed to a regular user, one that exists, it always sends me back those same 5 questions, no matter what, right? And so it became this fairly easy, request response that, hey, it ends up, being a user enumeration. It's fairly easy to run through, and you can, you can pull username lists all day long and actually exploit it. So just another flaw. It was an interesting one because it had to do with that randomization. It had to do with this fact that the developers, they've tried to eliminate the problem, but we always seem to push that down the road, especially with user enumeration, because it's so hard that we don't want to go to out of band, or we don't want to like use an email address. We don't want to use like other components that we have to allow for this what do they call it? Yeah, whatever. They want to allow for password reset, right? And
self-recovery, anyway, I guess would be
self-recovery. Yeah.
Automated recovery.
Yeah.
And that's the thing. That's the thing that's tough with enumeration too, is that for the general rule is the more vague or generic or simply lacking error messages are, typically then the more weight or workload you're putting on your support folks, your help desk folks, just simply because there's going to be more room for humans to have some friction and run into issues. And, it's like, okay, I work for GitHub. Most of our users are fairly technical, but not, a corporate website, you've got everybody from different positions within the company. So it can be fairly difficult to balance enumeration, and not just enumeration, but there's other places where there's error messages you may not want to present for, enumeration of, like, I'll use GitHub as an example, like repository, and organization enumeration, right? An NWO, name with something. I can't remember. Name with owner. Sorry, name with owner. Anyway, so you wouldn't want enumeration in those cases either. But again, like, as you don't provide super helpful error messages, your support burden goes up.
Yeah, and I was going to see if I can actually show some of the. I don't want to disclose the client, right? Like NDAs and everything else always, drop into that. But there was another.
Just ruin your business for us, Seth. If you cared,
I know.
You just ruin your livelihood and your career for us. So,
I was going to actually show another error message. Maybe if I can.
And I want to expand while you're looking up. Do I have time to expand upon something while you're looking something up? So this is the other thing about that becomes difficult, where you mentioned that you don't see it in just the login, you see it in other places. So like take an account update, for instance, especially when you're using like libraries or third parties, libraries within your application to do authentication. What will happen is you're essentially, overwriting classes and sort of including this library, which is taking over all the authentication bits, which means some of it's out of your control, right? One of those things is oftentimes a uniqueness key on certain attributes. So of course, like if you have a user table, an email attribute should be unique, right? You don't want everybody to have the same email address, but that presents issues when you talk about like account updates, where again, that's reusing something that's built in. It's a library that's handling that update. You can override the overridden library for sure in most cases to do something custom, but most people don't, right? So they go with the standard way that library operates, which includes the standard library, errors that library generates, which is uniqueness stuff, right? Whether that's email, username, whatever. So that becomes hard just because of the fact that like now you have to figure out where everywhere that you didn't code, you just included the library, you didn't code up these pages, where those generic messages are going to be shown, right? Because typically you're going to have like as part of your web page, you have your view, which has the header that's reusable, and it's just showing whatever errors are generated. So again, if the library is just generating those and you're just spitting out any errors that come out, you may not even be aware that, because you didn't code that error yourself, that it's doing some sort of disclosure enumeration just simply through uniqueness checks.
Yeah,
long-winded. Yep. I know, but it's important to understand that dynamic.
Yeah, it is. Okay, hold on, I'm going to show,
and why it's not always intentional that those error messages are showing on behalf of the first party developers, although very much intentional of the third party developers.
Yeah. And we see this quite often as well in like API calls, right? Because you're trying to be as descriptive as possible to the front end system as to what's going on, right? And so we leak out that same sort of detail, right? Yeah, and like it's not, again, like you said, it's not an intentional choice a lot of times, right? Yeah, but it happens.
And we've looked at apps that are connecting to other apps to do authentication, and like you're not even at that point. You're pretty far removed from authentication. You're just pretty much validating that they passed the authentication check, and getting back who the user is, and then that's setting their session presumably, and then that's from that point forward. In the application I'm thinking of, anyways, that's about the extent of your. So anything that's being written in that service that you're calling out to do authentication, it's like you may not even know if there were changes where an error was introduced, and allows for enumeration.
Yep. Yeah. And okay, so along those lines, let me show you the other error that I found here. And I did strip out some of the stuff, so we should be all right. Okay, let me see. Okay, so this
live.
Go live, yes. So this one was, this is during the user registration process as well, right? And it actually is probably arguably a more fatal flaw than the one that we've identified previously, but it is enumeration based. So let me share. Crap. My Google Chrome can't actually. Heck. Is there another way for me to share this? Dang it.
If not, I can tell a story while you're getting that all sorted. To explain why enumeration, because on its own, it's like, okay, great. You can, I think, okay, just real quick while you're figuring this all out. Enumeration on its own, usually people are like, okay, how's that like any kind of severity whatsoever, really, right? You're disclosing they exist. Great. Okay, what are you going to do with that? Now, the typical sort of baseline vanilla case that people point to is that, hey, like if you have an account lockout that isn't working, or is vulnerable. So or you just don't have an account lockout. If you also don't have like decent password complexity rules, So you have a case where there's no rate limit on attempting bad passwords, and you have passwords that are potentially weak. And then you can also enumerate one set of 2 credentials. Usually it's email address or username, but we'll just say email address for this case, and a password, right? You already know half the credentials if you can enumerate. Now, if there are other flaws with authentication that allow for you to do this sort of brute forcing login, that's kind of the vanilla case people talk about. But there are other very valid cases, and it usually is chained with other, almost always it's chained with other weaknesses in the application. So a good example would be 2 that come to mind are, a real simple one would be like IDOR. So let's say I'm able to, go ahead and perform some IDOR operation, update an account, but I need to have the email address. Like, let's say I'm doing a account update, and it takes, an email address, takes maybe a new password without any, old password required. Maybe it has some other attributes that you can update. So I need to know the email address of the other valid users in the application so I can update their password, just as like a vanilla case. This is a time where another weakness, IDOR, in the application leads to you using that enumeration to like create a really, really good practical attack. There are other weird ones, right? Like one we talk about in the secure code review course. One example we talked about is an application I had tested where you gave it an email address in your browser. You said, here's the password, here's the email account I want to reset a password for. So when you did that, you hit submit. The application sets a cookie, and it also in your browser, and it also sends you an email. And then so you would go into, and I'm guessing the hope was of the developers was that when you clicked on the password reset link, they emailed you that it has a token in it, that you're going to be opening that link in the same browser they set that cookie at, because that's what they use to determine which email account they're going to reset a password for. That's it. So they, like I said, just to real briefly cover that, you submit a email address into the application, sets a session that says essentially like, this is the email address of this user. Then when you go through the password reset flow separately, click on this link, gives you a token. That they validate that the token is good. They're not validating that the token is tied to any specific user. So they say the token's good. You can proceed forward to submit this form with the new password. And then when you do that, it reads the cookie that had been set in your browser to determine which user you're updating the password on. This is a real case. This is a real scenario. This was a real app that I looked at the code for and did some dynamic testing with. So if obviously I was able to enumerate email addresses, this would be problematic, right? Because obviously I can then just go through and start going through this process of resetting everybody's email addresses and then using valid tokens to, send the token to my appropriate email account, the browser that had somebody else's email address on there, and go through the flow on that browser. So anyways, those are a couple examples, vanilla cases of why enumeration can be a real problematic thing when coupled with other vulnerabilities.
And that's exactly what I wanted to show, right? Like with this screen share that I'll drop up here in a minute is how it can escalate, right? So the enumeration ability actually leads to the ability to actually, in this case, to brute force passwords, right? So we're looking at an error message here. During the registration flow, one of the options is to send a user a set of temporary credentials, right? So like a username and a password. But this gets overly descriptive. If you look at the error messages that are returned here, like I put in a username, and you'll notice that it gives me back a pretty specific error response in the username field during the registration flow. User has already registered their digital identity, right? So the this user ID obviously already exists within the scope of this application. But even better is I get a password description below that, which is the user ID and password. What is it? No, I can't.
Combination you entered doesn't match any entries in the system.
Yeah, exactly. And so I'm like, oh, awesome. Well, that's amazing, right? Because what happens when I put in my username and, so the next screenshot that I've got here, I got to flip back to that other screen if I can find it. So the other one here, right? Okay, here's the secondary or the next step in this process, which is user ID and password combination you entered doesn't match any entries in this system for the username field as well as the password field, right? And so, like at that point, that's the initial enumeration. But the third iteration, I didn't pull this one up. The third iteration here is with a valid username and a valid password. The only thing that you get is the response from the username error message and not the password error message, right? So you get user has already registered their digital identity, but there's no error message that comes in after password. So it's giving us the ability to actually brute force the username and passwords that are associated with it. And even better is if I brute force through this form as opposed to the login form, there's no account lockout associated with it. So I can, because who's going to brute force the registration process, right? They're going to brute force on the login screen and move on with it. So, and this was discovered in the past week, right? This is not something that is, hey, it was only 10, 12 years ago that we were actually seeing all of this. Yeah. All of the flaws, right? And, we talk about SQL injection stuff that we rarely find anymore. And it was more common, 10, 15 years ago than it is nowadays, but user enumeration is everywhere, which is the reason that I bring it up, because it is kind of a fun one that there's always different edge cases. That's what I wanted to say. There's always different edge cases that we run into. So.
It's definitely a challenge with social platforms where, they want you to know each other's basically part of the credentials that you use to log in, which is, your username typically, right? Your handle, whatever you've chosen for social media, that's typically what you log with. And it's a bit difficult because it's known. And in those cases, enumeration isn't necessarily such a big deal. And in some cases it still is. Sometimes they want the email address decoupled from the username, right? So there's, I guess a good example would be GitHub. We have a decoupled, we have the option for private emails so that we don't disclose your, whatever's been marked as a private email, it doesn't pop up. In any case, user enumeration becomes pretty difficult, because a lot of social sites, even in that case, you can log in through either the username or email address. So they really have to have a robust anti-ATO account takeover, anti-account takeover strategy, which usually is combining metrics about, when you last logged in, basically collecting. And I'm not saying this is just a generic. Just want to be very clear. This is just generic information, but typically you'll collect some sort of metrics that allow you to fingerprint effectively the person who's trying to log in tandem with, obviously two-factor authentic, or I should say multi-factor authentication. And then, particularly apps versus SMS, because, SIM swapping exists and it's pretty prevalent and all that good stuff. But still, two-factor auth, or multi-factor auth, whether it's text or apps, is still better than not having it at all, right? Also, you've got to have some pretty robust sort of like rate limiting and ability to withstand denial of service attacks. And then it goes to, that's just the login part. Then we talk about, like, you mentioned there's more to this than just the login page. There's also like forgot password type stuff, account updates. You've got to be mindful of it in many places. So for instance, putting in like high risk pseudo filters or high risk filters, where it's like, hey, re-log in because it's been, I don't know, a few hours since you last logged in and you want to like change your password or update your email address to something different or something like that, or you want to change out your keys, your security keys or whatever it is, like you should probably re-log in. So there's all these like other things around enumeration in terms of like, anti-account takeover strategies, but like enumeration is a funky one because it's not as black and white and easy at times as you would expect. So it's a fun
Yeah.
one. It's a fun one because it usually leads to some interesting conversations like this.
Yeah, and it leads to interesting flaws, and it definitely kind of shows a maturity of the threat landscape, or the analysis that's gone into the threat landscape for an application, when we start to find things like this, right? Because it does require you to take a step back and realize where you actually identify those users. And there's always those edge cases that they just throw a wrench in things, right? I know we could pull Justin on as well, and we've got so many war stories about user enumeration flaws in weird places because of the difficulty in actually solving that issue. And I've thrown up some of the web testing, web AppSec testing guide from OWASP, or the authentication cheat sheet. But even those don't go into depth in all the ways that we can fail here. I mean, granted, they're cheat sheets. They're they're kind of overviews or summaries on how to identify these issues. But, in the case of what we were looking at with the security questions, it's a positive negative response that doesn't actually give us an error message. So if you're only looking for error messages, you're going to miss that nuance of the security questions that come back randomly every time that you ask for an invalid username, right? And that positive negative, blind response that comes back is what we often miss as developers writing unit tests, as security people, because we're looking for the big glaring red letters that basically say, hey, there's a problem here and this is what the problem is, as opposed to kind of the nuances that go into it. So, if you're testing for these sorts of flaws, if you're developing an authentication system, let's just think about where that's actually happening. And this doesn't even push us into the cookie realm, that we use cookies for authentication, because that's a whole separate discussion that we could have, right? I think each of these that we dive into in the course, we spend a fair amount of time actually analyzing and stepping through, even in AppSec 101. So just an overview.
One thing I would love to see more of is, because we've got these various open source scanners that are doing they're looking for sort of your typical vanilla stuff, right? Like cross-site scripting, SQL injection, misconfigurations, things like that inside of applications, like Bandit, Brakeman, stuff like that, right? Open source scanners. But I'd love to see more that are focused on because a lot of these authentication, I don't know if you call them frameworks, but definitely libraries, popular libraries, ones that are that if you're working in that ecosystem, you've come across it multiple times, right? Like the popular ones. I'd love to see more scanners looking at these, because most of them operate through configuration files, as well as certain options inside of if it's an MVC app, controllers and models. There's configurations in the controller and models. There are also, but usually an actual legitimate configuration file that controls certain things like account lockouts, your strategies for recovery, things like that. And I'd love to see some scanners built to kind of parse those and quickly enumerate weaknesses and the choices people make. So if you're at all inspired to do such a thing, it would be very helpful to see more of that for free. We'll sponsor you or something. I can't promise it'll be much, but yeah. But anyways,
well, it's like we are seeing more and more of those kind of customized scanners or targeted scanning that happens against configurations and other things. Like think about SemGrep, think about some of the other tools that are out there, because I mean, security's become a bigger issue, right? 10 years ago, that sort of request probably would have gone by the wayside, because it's how do you do this for, .NET, ASP.NET applications, Java, struts applications, whatever, was popular back then, right? But nowadays, we do have scanners that are specific to those. If you've got access to the source code, you should be able to see what an auth0 configuration looks like, what, devise, how it's implementing different things on, on a Ruby on Rails application, or right, or the Django application. If you're using the built-in contrib auth functions, there's probably a way that we could suss this out pretty quickly if it was targeted, and it would be an interesting project to drop in there.
I did.
Yeah.
I did want to bring up real quick. Hoodie Pony Daniel brings up a good point about timing attacks. He kind of brought it up by saying he saw a situation where invalid credential returned immediately and valid but incorrect credentials returned took like a second or two. And I bring this up because I remember it was like maybe 2014, 2015. I think it was 2014-ish timeline around then, where there was quite a bit of debate about the efficacy of timing attacks and if it's like practical. But like, I think even then, I remember John Poulin, who now works with me, but Seth, John, myself, we've all worked together for years now. Anyways, John proved out, timing attacks work and had built, I think it was like a burp plugin or something to do it. And anyways, it was effective. He made a video on it. It's probably buried somewhere in the bowels of YouTube. I mean, maybe I can find it sometime, put it in our Slack channel. Anyways, why I say this is now, internet is like so quick and so reliable and dependable, and systems are so efficient, that I think it's actually more effective now. I think that you will be able to. The reason I say that is the primary argument that I remember people having was that there were the signal, they couldn't get a good baseline for what was like we're talking about milliseconds, right? So it's hard to get a good gauge when there's enough network noise and variances. It's hard to see, like just sort of even on a large scale of a lot of requests, like where's the variance, right? But now I don't think that's such a challenge. And I mean, I'm open to being wrong on this, but I do think like given how, what am I trying to say? How well things work. My assumption would be that the baseline would be easier to establish.
Well, I mean, it goes back to Moore's law, right? Everything gets quicker, and we're, from a CPU perspective, like everything is faster, like, and to your point, that argument years ago was probably pretty valid because of network paths, and you're going over some DSL link across to somebody's system, and it's hard to account for the speed and but nowadays, I've seen it within the past couple of months for sure, is that using these like the predicted, dang it, I'm like losing it today, Ken. The hashing, like the modern hashing adaptive hashing algorithms. There you go. I knew I was going to get there. So you're using bcrypt, you're using PBKDF2, the adaptive hashing algorithms to encrypt or to hash passwords. I almost said encrypt passwords. There we go. To hash passwords and then to check that hash. There is a work factor that's involved with that, right? So like bcrypt, it'll be a work factor of 12 or 20, depending on what you put. But if an invalid username comes in and you don't actually perform that work, you're going to return a lot quicker than you would if you were encrypting something or hashing something using one of those adaptive hashing algorithms. And that's an easy miss to make in code, right? Because you're just trying to get this feature out, and it's going to happen for sure. And I was trying to remember, I think I showed you one 6 months ago or so. I'd have to dig back through my archives, right? But we have seen those timing attacks work practically against applications within the last 6 months. And it's just going to get worse.
Yeah, and I mean, how do you solve that? I mean, I think the main way that we talk about solving this in today's world is through constant time comparisons. So you have to, I mean, I think like probably a lot of people watching this are familiar with this, but for those that aren't, you do have the ability with most crypto like libraries in general, whether it's, again, like it doesn't really matter which language you're using. There's usually a solid crypto library. Not usually. There's always crypto libraries built to do things, and the solid ones usually have this notion of a constant time comparison function where it, essentially it does an operation every single time to ensure that no matter what happens. So like, let's say we are looking up whether or not an email address exists. And then we're going to do something different, whether it exists or it doesn't exist, right? That in and of itself means there's going to be two separate branches of where this code executes. And that in turn means there's, of course, going to be some additional overhead involved, a database lookup, right? And then, of course, using maybe the object returned from the database in memory, doing something with that, whether it's loading the attributes, whatever. It's going to take up some compute resources, is my point. And if you have two different routes you can go or more, of course, there's going to be some different compute time really involved, and there's going to be variances. So the way you negate that is by ending that function routine with when you start the routine, doing a constant time comparison. And you will always return whatever, no matter what happens, no matter what operations continue to happen after that, you always return with the same amount of time during like an authentication function. So that's probably the main way that I've seen it prevented.
Yeah. So you say that, but I mean, honestly, how many developers have gone to the level of thinking about timing attacks? Right.
I don't know, but it's in our, I mean, for us, it's in our secure code requirements for that reason, because like you said, I don't think people do. You're right. I don't like, or maybe you're not, maybe you are just posing the question, but I think in that question, I think you're like, no, I don't think it's a common thought.
Well, so I kind of go back to like this. Yeah, we're all over the place today, Ken. But this goes back to like training of developers, like from a secure coding perspective, or even just like a security awareness perspective. Because it's one thing to be like, hey, you shouldn't have an error message that shows whether or not a user exists. That is a easy confirmation and an easy like problem to solve. Yes, Mark, you're right. It does depend on experience of the developer. But then you also have that, okay, where does that discussion lead, that you're actually starting to talk about the pros and cons of using adaptive hashing algorithms and branches in code as you're doing database lookups based on usernames and whether or not that returns a constant time, or at least a variable time that can't actually be predicted or tracked, that results in user enumeration, right? That flaw is so much more nuanced that I don't know how to push that out, right? Like this is where we start to depend on senior developers, to Mark's point, right? Developers with experience that have actually seen this in the past, or product security people that are aware that these issues pop up and can push that down and set those sorts of restrictions. But at a startup that's flying a million miles an hour trying to push out features, it's just not something that's going to come up, right? I know that it's not. So I kind of go back to how do you educate developers about these like nuanced flaws, outside of telling them to listen to our podcast, right, Ken?
Yeah, I mean, really, if you have a security team, that's why requirements, again, I'm going to point back to requirements. I think that's why it exists, because it is a baseline level of hygiene, right? And this could be, when we talk about in our requirements, when we talk about secure constant time comparisons, we also talk about it with like, I mean, it's not, of course you can use it for password comparisons, but you can do that for a lot of things. You do it for HMAC validation. You can do it for all kinds of interesting places where you need to do a comparison of two values, and don't want, variances in timing returns. So I think it's great to do education. I think Dave Ferguson, when he was on, made some good points about how little or how much, training is effective depending on how it's applied. There were nuances there for those who hadn't seen the episode. So again, it's not always black and white. I would say it's probably more often than not black and white. Anyways, Dave Ferguson brought up some good points, how to train people, what's effective, what's not. Go back and check out that episode if you haven't seen it. But I do think there's maybe a little bit of awareness and education, but ultimately you got to have secure code requirements to have a baseline level of hygiene, because no matter how well you educate people, It's not always going to be effective, but you know what is? Making people stick to requirements.
Yep. Requirements, a paved path, some way that, a security feature set that's already been implemented and is tried and true is definitely a better way to go about it rather than just, winging it. Right. I mean, in general, that's going to be a valid statement across the board. Cool. So the other flaw, I know we've only got 10, 15 minutes left, but the other flaw that I saw in the last week that was super interesting actually had to do with the use of a web application firewall sitting in front of an application. Application is running in a corporate environment, but the web application firewall is limiting access to certain functionality based on the location coming in. So you go through the web application firewall if you are coming from outside, right? Like you want to access this application, and it gives you access to a limited amount of functionality. If you're internal on the corporate network, it gives you access to the whole application, right? There's no restrictions. So there's certain administrative functions that are only accessible. Like if I want to change another user's password, you have to actually be on the VPN or on the corporate network in order to change another user's password. But if I want to change my own password, I can do that accessing the system on the internet at large, right? Through the web application firewall. Now, so it was running, I'm not going to dig too far into what the tech is, but the web application firewall was doing a match based on the URL and looking for say /admin, right, to do a password reset, and it would automatically kick you back to an error page if you couldn't access /admin or you're coming from the internet as large. But there are always this is always the case. There's always bypasses that are available, right? And this one went back to the error message that was actually being displayed behind the scenes when I started to introduce other character sets into the URL, right? So, okay, so back end, right? So you think about Apache.
Oh, I see. Yeah. Oh,
do you see where I'm going?
Sorry.
Okay.
Yeah,
so think about
that's awesome.
Apache. Think about how Apache does processing on the URL, right? Right? What is the first thing that it does when it gets a URL? It does a URL. It breaks it down, and it does URL decoding, right? So, in case there is something like, the question mark gets encoded as something else, or it's coming through a proxy that's been, encoded, whatever, right? And the web application firewall would understand the slashes, they go to a %2f, right? So it automatically decode those. But the different components in the path itself, like /admin, the second that I say change admin to a %61 DMIN, it would bypass the web application filter and allow that to go through. And Apache on the back end would automatically decode %61 to an A to /admin. So I was able to bypass the web application firewall restrictions on location just by changing, just by URL encoding characters, actual letter characters, as opposed to the normal what you would see in %2f for a slash or a %3d for an equal sign. So it's one of those misalignments as you're starting to talk about. That one was fun, right? The second that I got back an actual response coming externally to those, this is why we do security, is because it gives us a dopamine hit every once in a while, right, Ken? But yeah.
Well, but this is a double-edged sword, because how many times, I don't know, I'm sure this is, I know, never mind. This has definitely happened to you. I'm sure of it, because it's happened to me so many times where I have the code running locally. I'm looking at the code. I'm like, oh, that's a vulnerability for sure. I should be able to traverse, grab a file that's outside the whatever. I should be able to pull off some attack. Usually it has to do with manipulating the path, doing some traversal, stuff like that, right? Where then it works locally and you're like, oh, great, I just proved it out. Let me go do it on the production site. And then it's because it's a different stack, underlying web stack, like you said, locally it's probably, I mean, you can run Nginx locally, but usually it's some local, meant for just like WebRick, for instance, type stuff, like locally running web server. Not a lot, there's no proxy, reverse proxy type stuff. There's no load balancer. There's no underlying different server version, different version of the server, different type of server, stuff like that. So while it'll work in local development, you can definitely prove it out and be like, yeah, you're 100% vulnerable. I saw the code. I was able to prove it out locally. You can't pull it off on a production system. So that's why I say it's a double-edged sword. Sometimes it's kind of a pain because you're like, I have a super critical vuln. And yeah, it's still like a defense in depth type thing I probably wouldn't categorize it as defense in depth, but in terms of like a risk rating, but in terms of in my head, it's probably more of like, yeah, you should shore that up or you're not vulnerable as it stands right now.
Yeah.
But that's like frustrating as hell when you have such a cool vuln like that and you just can't get it to exploit in production systems.
Well,
Because of the web stack.
Yeah, because of the web stack, exactly. But this was interesting because it was like, okay, in the code itself, I'm not actually seeing this, right? This is only, it's implemented in Apache, like, they're deploying to Apache and the only reason I actually found this is because they wanted an actual test of those web application firewall rules, because this is a key control for this application. They don't want anyone to be able to access that sensitive functionality from an external IP address, right? And so the only place that was actually in play was their production instance. So this is a case where it's vulnerable into production, but nowhere else, right? Because they don't have those controls in place, right? And so I was just like, it's fascinating how the complexity of these different components, like the more complexity that we introduce, these edge cases pop up that we don't actually, we don't actually think about, we don't actually find unless you test it in that true environment where it's deployed in production and actually being used. So
when you're looking at that app, are you seeing a lack of authorization applied on those administrative endpoints? And then you're just like, but I'm confused. Yeah. Because I'm confused yeah.
Yeah. So no, not necessarily. Like, so if I log in as a regular user and not an administrator, even if I try and bypass bypass the web application firewall, it still will give me the typical internal response that I'm not authorized to like change someone else's password. But I have administrative credentials. I log in and I access that URL, and all of a sudden I can start changing things from an external it's not only changing other users' passwords.
So this isn't
like roles and other things. Yeah.
So this is missing function level access control or misconfigured, but it's not in the typical way where it's just missing. It's actually more of just, so it's not technically MIFLAC because authorization filters and decorators exist within the application, but it's that they are specifically attempting to prevent any outside entity who's obtained credentials or otherwise can get to administrative interface like validly, whether they stole a session or whatever it might be. It's preventing them from doing that from an external IP. So the only check is not within the application; it's within the WAF.
Yep. In that case, it's within the WAF. Yeah. Yeah. And so, but this kind of goes back to the stuff that James Kettle was talking, or is it like all his research with HTTP request smuggling as well, right? The second that you start playing with encoding and how like one proxy handles, or one web application firewall or Nginx, how that handles return characters as opposed to how Apache handles return characters behind the scenes, and you start to have these mismatch with sessions, with protective controls. When they fail, they can fail spectacularly, right? Is where I'm getting with that. It's kind of they're fun to explore. I'll be honest, like really fun to explore. But it's initially when I started looking at it, I was like, oh, they've got this regular expression that they've written into the web application firewall that seems to be doing things properly. And then the second that I started to see error responses come back from Apache that actually showed me the full path that I entered in there, and it was decoding the the %20 2Fs that were the slashes that I was pushing through, I was like, oh, it's doing decoding in one spot, but it's not doing it in another spot. And we've got mismatches and yeah.
Yeah, so it's enumeration just in a different context, just like
it is
blind versus error-based SQL injection. It's still enumeration. It's just in a different bend.
And then that was what I did, right? Like, so I'm pushing things through this web application firewall. One of the first things I did was I started to drop in different just tokens and other things that maybe weren't associated with the application, different tokens or different words to see what else was restricted on that server based on the web application firewall, because what else is considered sensitive, right? You can enumerate the sensitive endpoints based on the responses coming back from the web application firewall as well, not just from the application code. Because like Apache, right? Like, okay, they're running Tomcat. There's like a management application that's running underneath that, right? They don't want that accessible externally either, but you can use the same bypass methods to get past it. Anyway.
Yeah. Anyway. No, it's I see how you brought it all back around. That's what you did. You brought it all back around. Back to enumeration.
It's all related, right? Yeah, it's all
connected.
It's all connected. Yes.
Very cool. No, I love it. I love hearing the practical, and then it's just fun to hear something that is dynamic testing related too. I mean, that's fun, because we do so much on the code review side. I think I was telling you, I enjoy dynamic testing. I just don't get to do a ton of it, But yeah. And it's usually within a time box scenario. I'm usually like, this can be faster for me to look through code. But anyways, that's cool, man. Yep. That's pretty dope. Cool. Like, that's the fun part when people ask me about career progression, and I kind of talk about the like bouncing between different roles, meaning like, whether it's internal defender or corporate, like what are the pros and cons, like working for a company to defend them or being a consultant or something else. What are the professional trainer, like Jimmy, who we had on last week? What are the pros and cons? And I always tell them, like, the pros of being a consultant is that you get to look at new stuff and different stuff all the time. And it's funny because like, I think I told you this week that there's been a couple times over this last year where like there was a new technology and I learned about it from doing stuff, like our podcast, like the After Dark, not a new technology, but stuff that's new it's being introduced in my professional life, just through like our interactions and working on open source stuff and like the podcast and everything. I'm learning about it because I feel like consultants sometimes get to see first what especially if you're working with, tech companies, Silicon Valley styles, pushing the boundary type companies, you're going to see new technologies before, they get adopted at, say, the enterprise level. Yeah. So anyways, it's super cool. You get introduced to a lot of different things. And this is like one of those, and you get to vary between dynamic testing, code review. Maybe you're doing threat models. Maybe you're giving training. Maybe you're doing something entirely different. Like helping them build a program. You get a lot of like experience. So anyways, there are definitely still pros to heavy pros to doing consulting. I think the only con is the grind. It's quite a grind, and
it is,
and it's a pro and a negative. But sometimes how it goes, man. You got to get up to speed on a new technology quick. You may be told in 2 weeks or a week you're going to be, or it could be the end of the week, and they say on Monday you got a new stack you got to like look at. So figure it out, And so that's also a good thing, but it can also be a exhausting thing too.
Yeah. There's always something new. I mean, recently, and this too, we've mentioned it a couple of times that we've been getting pushed more and more into the Web3, like the blockchain space, because and the stuff that we're seeing on that side of the house is just wild, right? Like,
I'm sure.
Yeah. And super fun, but it's definitely pushing us in other directions. But that being said, we should have somebody
crypto high performance libraries.
Yeah.
I mean, now you have to think about different things. You've got some obviously some complicated, in a lot of cases, financial transactions going down. So it's a really new, awesome space to exist in. I think it's dope that you're like doing that.
it's been super interesting, right? Like, you know, we had Ken Toller on and talked about some of that in his space as well, right? Because it, like, if you go back to enumeration, you go back to timing attacks and smart contracts and how fast things actually execute on the different chains. And, you know, you have a slow chain that doesn't mine very quickly. What happens when that smart contract is out of date, or, you know, like it's wild, like some of the stuff you have to come up with and the threat analysis that you have to do, as opposed to a traditional web application that we've been doing for 20 years, right? Anyway,
Yeah.
so there's always something new to learn. You know, don't be afraid of it.
Yeah.
You can definitely learn. So, cool.
Yeah.
All right.
Well, Daniel had a question about
Oh, he did. Yeah, go ahead.
Yeah, no, I just want to answer Daniel's question real quick. Just some examples of like good authentication libraries. Passport comes to mind for like Node and Express. Devise for what is it? Rails.
Yeah.
I guess with Django, you mentioned the built-in contrib auth. I don't know what the popular ones within Django are, to be honest with you. You know, I'm kind of trying to look that up right now. I can't remember anymore what the good stuff was.
Discount like some of like the Auth0 libraries, right? Like I don't necessarily,
Auth0.
yeah, but
OmniAuth,
the providers,
but that's
OmniAuth,
kind of
yeah,
kind of,
that's authorization. But yeah, like Auth0, if you're using like AWS, like the libraries for like the identity stuff behind the scenes. I, as a developer, right, like coming at authentication, I'm going to look to offload that to someone that, like, yeah, friends don't let friends write their own authentication routines. They just don't, right? From a developer perspective, because it is so difficult and there's so many of these edge cases, it's much easier to go and depend on Auth0 and then suppress the error messages so you don't, like, you know, show the, you know, the front end that your you know, that username doesn't exist, right? At least like you can take it to that level and then depend on them to actually do the timing attacks and handle, you know, how that lookup happens, and yeah, protecting those passwords. And then it makes it easy to do things like MFA as well. So that's where I would push. Yeah,
100%. I agree. Yeah, I mean, definitely have MFA available and incentivize it as much as possible if you can. Like, I've heard of people giving discounts on their plans for enabling MFA. And if that's what you have to do to get your user base to use it, do it. It's going to save you money in the long run because of just the sheer amount of energy, time, the teams you have to build out. Like, account takeover shit is so terrible. That is a whole, like, that's a whole other field and world at times. So our platform health team, I love them. They're amazing. And it's a hard job.
Yes, it is. And I think I do have to mention, I think I just stole that from Leisure Suit Larry on our on the Slack channel. Don't let your friends roll their own auth framework. I think that got in my head. So
I smell a new t-shirt design.
Yes, exactly.
Or sticker or something. I don't know.
We'll figure
something out. Crocs and socks and AppSec, and yeah.
Friends don't let friends roll their own auth framework.
I love it.
Yeah. And then JWTs suck, right? Yeah, there we go. They don't. Sorry, I should. Yeah, but yeah.
Context matters, but yeah, don't use them for your like replacement for sessions. That's the general gist for web sessions.
All right, sweet,
cool.
Okay, all right. Well, yeah. Thanks everybody for joining today. It's been a good discussion. I appreciate all the interaction and everybody on Slack poking holes in our podcast episode. Anything else you want to add before we call it today, Ken?
Nope, but I did just set the channel topic to don't let your friends roll their own auth framework.
Awesome. Yep. Cool. And if you would like a t-shirt, hit me up on Slack. We'll get some addresses, physical addresses, and shirt size, and we'll go from there.
Oh, you know what? One thing we need to do, we need to get Shubs on here. Remember, we said we are going to do that.
Yeah.
Yes. I need to do that. Let me make a note here. Sorry. Okay. Cool. I just remembered. All right, man. Cool. We'll talk more.
All right. Thanks, everybody. We'll see y'all next week.